Alright, time for the math. Easy solution to discuss inverse hyperbolic functions and basically look at inverse hyperbolic sine, cosine, and tan functions. Basically, I showed my last video what hyperbolic functions were. Now look at the inverse. Again, if you see my other video, inverse, you would just write them as for inverse trig or whatnot. You just write it as this. So this is for inverse hyperbolic sine or sinh. And this one just corresponds to if you have a function x equals to hyperbolic sine h of y. So what we're doing is solving for y. And then so you switch x and y and solve for y. And this is a way of writing the inverse. And then similarly for a cosh or hyperbolic cos, you're going to have x is equal to, again, x is equal to cos h y. And similarly for tanh or hyperbolic tan inverse, just put the -1 up there. Again, this one's equal to tan hy. Now we should graph these ones first. I'm gonna just look at the graphs of the hyperbolic function, just so when we inverse them we have to make sure that it becomes a one-to-one function. I'll show you what I mean. So basically for inverse for hyperbolic sine, just not the inverse, regular one, the graph of it, this one is just equal to, well, you know, e to the x minus e to the -x over 2. And so basically, when you graph it, you could actually it's just a summation of two graphs, or a subtraction in this case. This is x, this is y. So if you were to graph it, you would graph it, actually, this would be an asymptote line, and this one is e to the x over 2. And that's this graph, and then similarly over here you'll get another graph like this, where this one is equal to e to the negative e to the -x over 2. So you got something like this, and then this hyperbolic sine is just the summation of these two graphs. These ones is going to be 0 here, and then it's actually going to go something like this, because this one's going closer to 0, so it's actually approaching this. And similarly here, this is approaching 0, so the summation is going to be something like this. So it's going to be approaching that. That's a bit messy here, but I'll show you if you were to graph it, use a graphing calculator. Let's say Google graphing. We'll just go to Google search. Let's go sinh x, as well as let's go e to the -x divided by 2, and and negative e to the negative. This would be x divided by 2. Let's see, yeah, I'll show you. Then if you go change this to vertical, zoom in better. Actually, yeah, this one's not times, it's for the squared up there. Okay, yeah, so then again, if you were to zoom in, just to make it zoom in the vertically, because it's too big of a scale. And as you can see, that's exactly what I had before. So yeah, you had these. This is the e to the -x, negative e to the -x divided by 2. And as you can see, the hyperbolic sine is actually in between those. Okay, and yeah, this one is just hyperbolic sine of x. So that's how this graph would look like. And then if you were to take the inverse of this one, remember, inverse is just a reflection off the y equals x line. And this one, as you can see, this is a one-to-one function, so when you reflect, it's going to be one-to-one. And so then if you were just to draw a vertical line directly across it, so I'll just do it on the graphing calculator. Let's just go here and write x, y equals x. Okay, so yeah, I just zoomed in a bit better here. So as you can see, this is the y equals x line here, and there's a hyperbolic one. Remember, it's a reflection off of it. So then if you have h, let's go. Yeah, actually, Google calculator doesn't. Well, I don't know how to actually graph arc sinh of x, but we can derive it. But anyways, it's gonna be a reflection off this line anyway. So it's gonna be something like this right here. It's gonna be something like this one. Will probably look something like this, and then go down like that. So this would be sinh negative 1 of x. Once I derive it, we could graph it, because I'm not sure how to do it with Google. But anyways, this one is fine. And then if we look at y is equal to cosh of x, and how to graph this one, again, this one's equal to e to the x, this one plus e to the negative x over 2. And this one, again, it's the summation of two functions. So this one is going to be, this is going to be x, y. E to the x is actually the graph of this one is going to be something like this. It's e to the x over 2. And then e to the negative x over 2 is going to be something like this, right across here, where it's exactly the same here. And it goes to 0 there. And this one is e to the negative x over 2. And then just this is a summation of it, so it's actually going to look something like this. Whereas further goes out here, this is 0, so this is asymptotes over there, and it goes something like that. So this is cosh of h of x. And then if you were to reflect it off the y equals x line to get the hyperbolic sign, so let's just graph it like this. It looks something like that. This is y equals x line. This would reflect this one actually off it would look something like this. This one's actually at here. It would be something like this. So this point here would go here, and it would actually go something like this. Well, if you put actually this one's x equals 0 here, 0, you're gonna have, this is 1 plus 1. This is 2 over 2. So this is actually 1. So this one's gonna be 1 0. And that's actually this one's 0 1. That's that point. So if you were to graph this, the inverse would look something like this, and then it would actually go like this, because there's a mirror image around there. But then you can't have this. This one will have two values at each x. So this one, so you will have to define it such that we get rid of this one actually. So we get rid of this one. We define such that y is greater than equal to 0. And then actually if this is, let's say, yeah, if this would be cosh inverse of x. Yeah, so, but then this is greater than 0, you add this limit so that we don't have a one-to-one function, so it's actually just going to be this one. And if you look at it, it'll just be something like this. So this is the cosh of x, and this is 1. Okay, so now let's look at, let's look basically at y is equal to tan h of x first. This one, again, this one is just the two functions. Yeah, this one equals to sinh of x divided by hyperbolic cosh of x. So it's just a division of these two functions. So we're gonna have a division of, let's say this one is, it looks something like this. This is sine. So then we're gonna be dividing it by basically cos. This one's like this, or something like that. So then if we were to draw basically what tangent, it's a division of these two. So then we would actually have something like this, where let's say at 0 we'll have y is equal to 1 divided by y equals to 0. So we're gonna, 0 divided by 1. So we're gonna have 0. And then at the ends here, we know that this is actually an asymptote. This asymptote is e to the x over 2, and this is actually the same asymptote right here. This one's, yeah, there's the same asymptote right here. This one is e to the x over 2. Well, this is not a negative, it's that's an arrow. So then over here, we're gonna at infinity, we're actually gonna have this divided by this, and it's approaching 1. So it's actually approaching 1 here. Let's go y. This is x. So it's actually approaching 1. So it'll actually look something like this. And then again, similarly over here, we actually have something like this. This is e to the negative x over 2. Actually, negative e to the, that's the asymptote there, and this one as well. This one is actually something like this one. This one is just e to the negative x over 2. So we're going to have a negative e to the negative x over 2 divided by e to the positive. This is a positive. So we're going to have a negative 1. Because these are the exact same. So at negative infinity, it's actually going to another asymptote. So it's actually going to be approaching, well, approaching y is equal to negative 1. And then this one would just look something like this. And then if you were to draw the inverse, again, you would just draw the y is equal to x line. Will look something like this. This y is equal to x, and remember it's a mirror image across this one, so it's actually going to be something like, yeah, it will actually look something like this. This is the y equals negative 1, x equals negative 1. I mean, this is y is equal to 1, x equals to 1, but then if inverse, it's going to be the other way around. We're going to have x is equal to 1, and then x equal to negative 1. These are the asymptotes now. So it'll actually look something like this. And then at positive infinity, now it's gonna actually it's gonna reflect it like this now. Actually, I'll just draw it down here. Is we're just switching it. So then basically this is the new asymptotes. X equals 1 and x equals to negative 1, and it's gonna look something like this. And this one is y is equal to tan inverse hyperbolic tan of x. And this is, yeah, and it's exactly the mirror image across this line. So it's gonna be something like, yeah, it's gonna be it's a mirror image of that across the y equals x line. So now if we were to derive what they actually equal, so we know that how the graphs look like now. So from the graphs we know that the only restriction is for y is equal to cosh of x. The other ones don't have any restrictions because this one's 1 to 1 is for y is greater than equal to 0. So that's the only restriction for that. The other ones don't have any restrictions. And then if we were to derive what they equal to, well, let's just write it down here. We got, well, let's go with sin this one. Let's go y is equal to this. So this is just another way of writing x is equal to sin h of y. And then we know what they equal, so we're gonna have x equal to x is equal to sin y is equal to e to the y minus e to the negative y over 2. Just times the 2 out, so we're gonna have 2x is equal to e to the y minus e to the negative y. And then what we could actually do here is just put everything to this one side. We're gonna actually have 0 is equal to, show you what I'm gonna do soon, to the x minus e to the negative y. Now we're gonna, this is actually a quadratic formula. All we have to do is times everything by e to the y. And 0 times e to the y is 0, so we're gonna have 0 is equal to e to the y squared, that's all squared is, negative 2ey x, and then e to the negative y times e to the y is just equal to 1. Now this is just a quadratic formula, and then we put it in there, a quadratic formula. We're gonna have we're gonna have e to the y is equal to, so it's equal to, well, put in the quadratic formula, this is gonna be basically a negative, this is negative 2x plus or minus this b as well in here. This is negative 2x squared minus 4ac 4 times, yeah, negative 1, and this is just equal to divided by 2 times, yeah, just divided by 2. Basically, I'll just do a little sidetrack here. If you have 0 is equal to ax squared plus bx plus c, and the quadratic formula is just x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And in this case, b is negative 2x. There's a negative 2x. C is negative 1, and a is 1. So then we're going to have something like that. That's just a quadratic formula there. And you can see my proof on that one too, in my other video. So now this one, if you simplify this one, we're gonna get e to the y is equal to, this is 2x plus or minus square root. This is this is 4x squared plus 4 all divided by 2. And then if we were to simplify this further, this is going to be equal to 2x plus or minus, well, we could take the 4 out actually. We're going to actually have 2 is a number if you times it inside. 2, this is x squared plus 1. Because if you were to times it inside, you would just square it in there, you'll get it there. So basically, yeah, we can get it out like that, divided by 2. And then this is equals to x plus or minus square root x squared plus 1. E to the y is equal to that. But with this exponential functions, e to the y is actually greater than, this one's greater than equal to 0. It can't be less. So then we don't need this plus. I mean, we don't need this negative. So we can't be negative. So it's just gonna be x equals plus square root, because it's only defined for that. And then if we were to solve for y, we just ln both sides. So we're going to have ln e to the y is equal to ln of what's it, x plus and that's this one just equals to y. So y is equal to ln x plus square root x plus 1. Yeah, and if we were to look at, let's say, y is equal to inverse hyperbolic cosh of x, this one is very similar to this one. Again, if we were to switch this to, this is x equals cosh h y, and then so then if you write this one out, it's going to just equal to e to the y. This is a plus e to the negative y over 2. And then doing the same exact method here, we're going to get actually, because it would just rearrange this one, but now instead of a negative, we have a positive. So if we keep looking at the e to the y, what happens to it? Times it becomes negative 1 here, but for the other case, it's going to be positive 1. So this positive 1, this only affects the quadratic formula in positive, so only this one here. So instead of negative times negative, it's going to be negative times positive, it's going to be negative 4. And then again, you do all this one, we're going to end up with negative 1. So doing this similarly, we'll just get y is equal to ln of x plus x squared minus 1. And in this case, this one can't be less than 0. So x has to be greater than equal to 1. And that's actually exactly how this little, the inverse is right here. So x here, this is x, this is y of this one, so x again is greater than equal to 1. And this is exactly how the derivation we just have, which is the same thing. I just don't want to do it again because we're going to do the exact same thing. So there is the that's the inverse function. So now if we look at y is equal to tan h inverse of x. Yeah, so now we're gonna do the same thing as above. We're gonna get switches equals to x equals tan h y, and then from here we will just again just keep writing what we know. So tan h y is just equal to hyperbolic sine over y divided by hyperbolic cos h y, and this one is just equal to, well, we know that this is just equal to e to the y minus e to the negative y. Well, it's divided by 2, but we'll just write divided by 2 over here because they're going to cancel. Divided by e to the y plus e to the negative y, which is this, and 1 over 2. And these just cancel. So we're just left with these two right here. So we're going to be left with x is equal to e to the y minus e to the negative y divided by e to the y plus e to the negative y. And then again, we're going to rearrange this one. So we're going to have just times this, get this over to this side. So we're going to have x times e to the y plus x times e to the negative y. Just times it out in there. equals to e to the y minus e to the negative y. And now what we're going to do here is times everything by e to the y. So e to the y. Just so we can cancel these e to the negative y's out. So this one we're going to be here, we're going to get x e to the y squared plus this one, they cancel, so we're just going to be plus with x is equal to, again in this case, e to the y squared minus 1 here. So now what we're going to do is actually going to shift the 1 over this side and put this over this side. So we're going to have 1 plus x is equal to e to the y squared minus x e to the y squared. And this one just simplifies to e to the y squared 1 minus x. We just got to get it out of the bracket. Then make this by itself. So we're going to get left with e to the y squared just divided by 1 over x. 1 plus x divided by 1 minus x. And now here we can square root both sides. Square root, we're going to have a plus or minus here. Yeah, this one's actually plus or minus. So we're left with e to the y is equal to plus or minus 1 plus x, 1 minus x. But this one again, this is greater than 0. It's greater than equal to 0, so we don't need we can't use this negative, so this just equals to positive 1 plus x, 1 minus x. Then lawning both sides, we're going to have ln e to the y is equal to ln square root 1 plus x, 1 minus x. Again, this one is equal to ln 1 plus x, 1 minus x. This is 1 over 2. And then remember with lns, the log rule, you just bring it down here. So and this one is just equal to y. So we're going to left with y is equal to 1 over 2, 1 plus x, 1 minus x. Yeah, I mean ln of this. So yeah, there is our, yeah, that's basically our derivative. And in this case here, and with ln, they're not defined for negative x values. So in this case, this can't be negative. So we're actually going to have x is actually less than equal to, yeah, it's less than 1 in this case, because if it's greater than 1, this becomes negative. And it's actually greater than negative 1. Yeah, it's greater than negative 1, because if it was less than negative 1, this top would be negative, and this wouldn't be defined. And this actually fits in well with our when we draw the inverse here, where we have x equals 1. So we have this range as well. So this is actually, yeah, this is right on. So our derivation was correct. And now to summarize, I'll just put all the stuff we found right here. Summary. Yeah, so y equals hyperbolic sine hx plus square root x plus 1. And this one is for, well, x is all real numbers. We can just write this. Probably seen this before. All real numbers. Or x is an element of all real numbers. Okay, so and then for y is equal to cosh negative 1 of x equals to ln x plus x squared minus 1. And this one is defined only for x greater than and equal to 1. And similarly for tan h inverse of x is equal to 1 over 2 ln 1 plus x, 1 minus x. So this is what we derived, and x is less than 1, less than negative 1. Greater than negative 1. And yeah, this is basically all for today. It's a long video, but this is basically all you need about inverse hyperbolic functions and how you derive them. That's all for today. Hopefully you learned, and stay tuned for another math easy solution. Oh, wow, this is pretty long.